Hi and welcome to Similar Shapes Lengths. Just before we start, just a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. So just to begin with, a quick definition. For shapes to be similar, the corresponding angles must be equal and the corresponding sides must be in the same ratio. Now basically what this means is the shape must just be an enlargement where all of the sides have increased by the same scale factor and all of the angles have remained exactly the same size. And so all I want to do here is just check with these different shapes that we've got here. We've got 8 different triangles. Which of them would be similar to each other? Well, the first point to make is when it is a triangle, if the sides are just an enlargement, then it does tell us, in fact, that all of the angles must have remained the same. And so this first one has a height of 2 and a base of 4. Now, if I enlarge this shape, the hypotenuse, the longest side in that right angle triangle, will increase by the same factor. So I need to find any other shapes which would be a multiple of these sizes. So 2 and 4, basically it would be a ratio of 2 to 4. It means that actually the ratio is the same as 1 to 2. So basically the base must be double the height. So are there any other shapes that are in that formation? Well, if I have a look at C, that is 3 and 6. That is a ratio of 1 to 2. And therefore A and C would be similar. If I have a look at F, well, that is a height of 4 and a base of 8. And so that is a ratio of 1 to 2. Those 3 shapes would all be similar. So A, C and F. If we have a look at B, B has a length of 1 and a length of 4. And so that is our ratio we're looking for here, 1 to 4, meaning that the base must be 4 times the size of the height. Now, have we got that anywhere else? Well, having a look at these shapes, none of those would seem to match that. So B doesn't actually have any similar shape. If we look at G, G has a base of 2 and a height of 5, and so that is a ratio of 2 to 5, and that would mean that for it to be similar, the sides would have to be in the same ratio of 2 to 5. If we have a look around, well, E and D don't look the same, but H, that has 2 and it has 5, but it's the wrong way round. Does that matter? No. If we are looking for similar shapes can be in any orientation. They can be reflections, they can be rotations. They just need to have the same angles and the same sides sides in the same ratio, and therefore G and H are similar triangles. So finally, if we have a look at D, D is 2 by 2, and actually, so that means if it's 2 to 2 as a ratio, that's the same as 1 to 1. It just means that the base and the height must be exactly the same. Well, we've only got one other option. We have E, and if we look at their sides, well, that's 4 and 4. They have the same base and the same height, and therefore they are similar triangles. That would be D and E. What we're going to look at next is the situation where we have been told that similarity exists. So if 2 shapes are similar, we are being told that the angles are all the same and that the corresponding sides are in a corresponding ratio. And so shape A and shape B are similar. Find the length of the sides marked X and Y. Now with this, what we're basically saying is that A has been enlarged to create B. And so what we need to do is we need to find a scale factor. And that scale factor just comes from big divided by small. If we can do that, we can find the scale factor between the 2 shapes. And so in the big shape and the small shape, we need to find a point where we have corresponding sides, where we know all of the information. And in this case, it's down here at the bottom. We know the base in each case. And so, in the bigger shape, it has a size of 8. In the smaller shape, it has a length of 4. And therefore, the scale factor is 8 divided by 4. It is 2. And so, to take me from A to B is a scale factor of 2. And so, let's find x. Well, x must be this side here, and it matches with this side here. And therefore, we have to do 3 times 2. And so, x must be 6 centimetres. With y, we have to be careful here that y is this side and it matches with this side, but y is the smaller version this time, and so the scale factor actually needs to go in the opposite direction. We need to go from 3.6 to the smaller version, and so instead of multiplying, we will divide. So we'll divide by 2 instead. 3.6 divided by 2, well, that is 1.8 centimetres. See if we can do the same with these two shapes. So I've got two triangles here, and it tells me that shape C and shape D are similar. Find the length of the sides marked S and T. Now with this one, it's very important that we understand the notation that has been used here. Now what this is saying, by using different numbers of lines, it's telling us which angles correspond to each other. Therefore, the one which has a single line corresponds to the angle which has a single line in the other shape. The one which has 2 lines corresponds to the one that has 2 lines. And finally, the one that has 3 lines corresponds to the one that has 3 lines. And so here you'll notice that the shapes are in completely different orientations, but the corresponding sides still need to be matched up. And the way to do that is to check what is between different colours. So between pink and blue is a length of 6. In between pink and blue on the other one is 9. And so what that means is that is a pair of corresponding sides. And so if I want to get the scale factor, well, here I can see that D is actually the larger of the two triangles. And so the scale factor is 9 over 6. And so that's actually the same as 3 over 2, or 1.5 if you want it as a decimal. And so then we need to find the values of S and T. And so what we need to do is we need to work out which sides they correspond to. So S is between green and blue. And so that must correspond to the side which is 6. So S is going to be 6. And because we know that C is the smaller shape, it's going to be a divide. We're going to divide by 1.5. 6 divided by 1.5 is actually 4. So S will be 4 centimetres. And then finally, it's quite clear because it's the only side left, but the 3 centimetres must correspond to T because that is between the green and the pink. And T and D is the larger of the two, and therefore we're going to go with our 3 centimetres, and this time we're going to multiply by 1.5. And so 3 times 1.5 is 4.5 centimetres. In our final set of examples, we're going to be dealing with situations where we have parallel lines included. And so with this, we have a pair of parallel lines which have been joined together, and it's created triangles. And it tells us that line AB is parallel to line DE, so calculate the length of X. Now, if there is nothing here to state that the shapes are similar, but if we think about parallel lines, we often start thinking about Z shapes, X shapes and F shapes. And so what I want to do here is I just want to have a look quickly at that. So if I take the line AB, the line BD and the line DE, it forms a Z shape. Now that means I have alternate angles, and the rule for alternate angles is that alternate angles are equal, and so those two angles must be exactly the same. If I take a different colour and I look at B to A and A to E and E to D, well, that is a Z shape again. It means I have more alternate angles. It means that this angle here must be exactly the same as this angle here. And there's one more section. I have here just two lines which cross, which intersect. And so that means I have vertically opposite angles. And if they are vertically opposite, they are also equal. And so what this tells me is that those two triangles are similar, because if all of the angles in a triangle are the same, then it just means that we have an enlarged version of them. And so now it comes to doing the actual calculations. We need to find a match between the two triangles. And so if we look here, between the red and blue, we have 7.8, and between the red and the blue, we have 3. So if I want to get the scale factor, well, that's going to be 7.8 over 3. 7.8 divided by 3, well, that is 2.6. And so our scale factor is 2.6. How are we then going to get x? Well, again, we need to work out a match. Where is the match for x? Well, x is between red and green, and so it needs to match with the side between red and green on the other side, 2.8. Now, x is from the larger triangle, and so if I want to get x, I'm going to have to do the 2.8 from the smaller triangle multiplied by our scale factor. And so 2.8 times 2.6, if we do that on a calculator, 2.8 times 2.6, that is 7.28 centimetres. Next we have two triangles which are actually formed within each other, but with the base of both triangles being parallel to each other. So line BC is parallel to line DE, and AD is 15 centimetres. Calculate the length BD. So first of all, again, we have parallel lines. So again, I just want to be thinking about how does this actually prove there is similarity? Well, if I draw in a line here, which takes into account the two parallel lines, I have an F shape. Now, an F shape means corresponding angles. And so what that is telling me is that this angle here, ABC, is exactly the same as the angle BDE. Those two angles are the same. If we do exactly the same on the right hand side, draw a line down and then across on our parallel lines, well, again, we have another F shape. We have corresponding angles again, and therefore ACB and CED are equal angles. They are the same size. And then if we think about the angle right at the top, well, it is the same angle for both triangles, because both triangles include that angle. And therefore we've proved we have similar triangles, and therefore we can use our ideas of scale factors. Which sides are corresponding? Well, this 9 centimetres obviously corresponds to the 12 centimetres here, because they are the two bases of the triangle. And so the scale factor in this case is going to be 12 over 9, which is 4 over 3. Now, I need to find the length DB. Now, DB actually does not correspond to any side in the other triangle, because it is not part of a triangle. DB is only part of this trapezium. So the first thing I actually need to work out is this length here, AB. I need to find AB because AB will correspond to the 15 centimetres going all the way from A to D. And so AB would be 15 divided by 4 over 3, because I want to get to the smaller version. And if I type 15 divided by 4 over 3 into a calculator, I get 11.25. And so the length here is 11.25. So how do I work out what DB is? Well, DB is the remainder of that line. and therefore DB would be 15 take away 11.25. 15 take away 11.25 is 3.75 centimetres. And so we end with the exam question. It came from the Edexcel paper in November 2017 and it was on Higher Paper 1. It's been stated that the two triangles in the diagram are similar. There are two possible values of x. Work out each of these values, state any assumptions you make in your working. Now for this question, the word assumptions is actually very important here because what we actually do, our brains will automatically suggest that the corresponding angles within this shape are the ones which are in the same place. So we would assume, first of all, that this angle corresponds to this angle and that this angle would correspond to this angle. That is just what our brain is naturally telling us about this diagram. And so for that we can work out our scale factors, because we can say that the length between the blue and the red in the smaller version is 12, and the length between the blue and the red in the larger version, well, that will be 15. So our scale factor will be 15 over 12, or we could simplify that to 5 over 4. And so if we use the scale factor with the other side of it, well, we can say that 8 would correspond with AC, and so the total length would be 8 times 5 over 4, and that would be 8 times 5 is 40, divided by 4 is 10, so that would be the entire length at 10 centimetres, but we only want to find x, and so we would need to take away the 8 centimetres here, so 10 take away 8 is 2. So the first possible value of x would be 2 centimetres. And that's pretty straightforward, just using the same ideas as we did before. But that is not necessarily the way that this diagram is set up. We weren't given any notice to say that they had parallel lines or anything like that, so our assumption may not necessarily be true. Where we assumed that this angle was the same as D, it may actually be that this triangle has been flipped over and it actually corresponds to this angle here. The angle B, well, that would then correspond to angle D. And the angle A, well, that is part of both triangles, so would remain the same. And so in this case, if we were looking at the scale factors, well, the length AB is 8 centimetres, but that corresponds to the length AD. And so our scale factor in this case would be the 15 in the larger would be compared with the 8 in the smaller. And so then what we would need to do is we would then need to compare the corresponding sides again. So A to C would actually correspond to this 12, and therefore I would have to do 12 times my scale factor, 12 times 15 over 8, and that's a little bit tricky, but 12 times 15, well, that is 150, 180 all over 8, and if I divide that, that would be halving to get 90, halving, so 90 over 4, half that, 45 over 2, half that, we get 22.5. But then, what length would I need to subtract in order to get just the length x? Well, I would need to take away that length of 8. So 22.5 take away 8 is 14.5 centimetres. This question has caused an awful lot of problems for a lot of people because a lot of people spot the first version quite easily, but the second version is a little bit trickier. You've always got to be just aware that sometimes they will try to trick you in exam questions.